Today we're working with the spring scale. The spring scale will pull up the same amount that the weight is pulling down on it. And that amount of force will be read on the scale. So right now this scale is reading about 9 newtons, which might not be accurate because the scale that I picked out of the cabinet was kind of old. But what we have today is a 1 kilogram mass, or it's about 1 kilogram. And 1 kilogram is about 9.8 newtons. So either that kilogram's a little off or the scale's a little off. So we're reading 9 newtons today, and we're just going to assume that the mass that's hanging there pulls down with 9 newtons and the spring scale pulls up with 9 newtons. This means that the entire system, the mass and the scale all connected together, has an upward force of plus 9 and a downward force of minus 9. So the overall force is 0. So with balanced forces, it just stays put at rest. And now we're going to look into what happens if the force upwards is larger, or if I don't pull up very hard, if the force downwards from the weight is larger. Oh, did you see what happened there? I didn't pull up with enough force, so everything dropped. The upward force was smaller than the weight, so the whole system accelerated downward. Ultimately, the scale just reads how much force I am pulling up with. So you notice that the scale went down to read about 6 there. So 6 newtons around there is less than 9 newtons, and so the overall force is downward by 3 newtons. You can kind of see that happen here in slow motion. I don't pull up with as much force, so now it's, look, all the way down to 4 newtons. So smaller force is pulling up, maybe 4, and 9 newtons is pulling down. Hence the acceleration was downward. And as everything settles down, the spring scale reads around 9 newtons again. 9 up, 9 down, and balanced forces. Now let's see what happens if the larger force is upwards. If I pull up with a larger force, then the scale will read larger than 9 newtons, and so the bodies will accelerate upward. The overall sum of the forces, or net force, is upward, so the acceleration is upward.